Okay, so this is November 2021, paper 6-1. It says it is known that the height in h in meters of a certain kind has the distribution this. So h has the distribution this. A scientist takes a random sample of 25 meters trees of this kind and finds the sample mean h bar of the heights. State the distribution of h bar. So h bar is also normally distributed with the same mean, but with variance divided by n. So I get 12.5 and 10.24 divided by 25 gives me 0.4096. Okay, that is the distribution of the sample mean as we've learned in sampling and estimation. Okay, then it says find the probability of h bar between 12 and 13. So I need to subtract the mean, divide by the uh Nawal, are you a science student? Okay. तो बेटा आपने ये पढ़ा होगा ना कि x bar is normally distributed with mu and sigma square divided by n if x is distributed by this. ये topic होता है, it's called distribution of the sample mean. Okay. So इसमें ये rule follow हो रहा होता है कि if x is normally distributed with this, then x bar must also be normally distributed with just a division of n. Okay. फिर in the next question, what I'm doing is this. Okay. So I get phi of 0.781 minus phi of minus 0.781, phi of 0.781. So 0.781 gives me 0.781. This gives me 7826. Okay. Okay, that's the correct answer. Moving on to the next question. It says the number of inquiries received per day at a customer service desk has a Poisson distribution with mean 4.2. So lambda is 45.2. If more than 60 inquiries are received in a day, the customer service desk cannot deal with them all. Use a suitable approximation distribution to find the probability that on a random day, the customer service desk cannot deal with all the queries that are received. So when it says using a suitable approximation, I am supposed to think So this, since this Poisson distribution has lambda that is greater than 15, I'm going to convert it into a normal distribution. Now, to find out that the customer service desk will not be able to respond to all the queries, it means that I need to find the probability of x greater than 60. It's by continuity correction. I get probability of x greater than 60.5. Then I convert it into a z value with a Poisson distribution has the same variance as well, so 45.2. That gives me z greater than 2.276. Okay, 2.276 on the normal distribution table is 2.2.9884 plus 2 to 9886. Okay, yeah. 1 minus phi of 2.276. 0114. Okay, that's the correct answer. And question number three, it says a random sample of 75 students of a large college was selected for a survey. 15 of these students said that they owned a car. From this result, find an approximate alpha percent confidence interval, probably the proportion of all from this result, an approximate alpha percent confidence interval for the proportion of all students at the college who own a car was calculated. The width of this interval was found to be 0.162. Calculate the value of alpha correct to two significant figures. Now, this is about the confidence interval of a proportion, which looks something like this. It is proportion from the sample minus z value into root pq over n, where p and q are proportions of the sample. Now, when I'm talking about the width is always the width can be calculated directly, and it's 2 z value into root of pq over n. In this case, the question is telling me that the width is 0.162. So I'm going to keep this here. P is 15 out of 75, and therefore Q is 60 out of 75. N is 75, equals to 0.162. Now, when I move these numbers to the other side, what do I get? 0.162 divided by 2 and divided by root of um, I am getting 1.753. Now, to read the z value of 1.753, that gives me that the probability that must be there 1.75 and 3. That gives me 1.9602. Now, this is a little tricky from here. Remember that what I'm now talking about is that in the case of the confidence interval, this 0.96202 represents this entire area. But since confidence intervals are two-sided, what I'm going to have to do is find this area and subtract it again from 0.9602. What's going to happen is so that this becomes a symmetric confidence interval. What I'm doing is finding out this area in green. and also including it here. That gives me 0.9204. To three significant figures, it's 92% confidence interval. This last part, okay, what I said was कि ये value जो है 9602 का मतलब है ये सारा एरिया, बट कॉन्फिडेंस इंटरवल्स जो होते हैं वो हमेशा सिमेट्रिक होते हैं. So what I need is I need this same area on this other side as well. I want this confidence interval to be just this area. So what I did was I found out this area and I subtracted it again. Okay. Does that make sense? Okay. Then it says question number 4. A random variable x has a probability distribution function this. Notice that this is a quadratic function. For 0 otherwise, find the probability of x less than 1.2. So this is a simple integration question. So 1 over 18, 9 minus x squared, 0 to 1.2. Okay, I can pull out 1 over 18. And 9 minus x squared को integrate करना है. I'll put in the limits. I've just ignored the limits for now. 9x minus x cubed over 3. And the limits are 0 to 1.2. So first inserting the limit for 1.2. Okay, what do I get? Point 568. Okay, that's the correct answer. Find expectation of x. So the formula for expectation of x is x f of x. And the range is always all values of x, 0 to 3. So I'm going to do the same thing again. This time I have to take all values of x. I'm going to move it to one side, and this becomes 9x. So the integration becomes 9x squared divided by 2. That becomes x cubed, so it becomes x power 4 over 4. And I have to integrate on all values of x. One 1.125. Okay. Okay. Easy question. Then says the median of x is m. Show that m cube minus 27 m plus 27. Remember that I just have to show, I don't have to solve this cubic equation. So whenever you are doing the median, it basically means that आप integrate करें from 0 to m, and your probability of integration should come out to be 0.5. So again 1 over 18 बाहर आ गया, and I have 9 minus x squared equals to 0.5. What I can do is I can multiply this on the other side, makes it simpler, and integrate on this side from 0 to m. That gives me 0.5 into 18 is 9. Just a moment. Okay. So I get 9m minus m cube minus 0 equals 0 minus 0 equals to 9. Uh, x cube over 3. Sorry, my bad. 9m minus m cube over 3 equals to 9. So I take the common denominator. 27m minus m cube equals to 27. 20, sorry, 9. And then when I cross multiply it, everything. Okay, that's enough of a proof. We don't need to show it every step on algebra. हम ना rarely will you have to do the first method. Generally, ज़्यादातर questions यही होते हैं. You have to show me a question जहाँ पे वो average of range निकालनी हो. Sometimes what I can tell you from here though is कि अगर आप um, इस क्वेश्चन में वो अप्लाई नहीं हो रहा शायद. हाँ, इस क्वेश्चन में वो अप्लाई नहीं हो रहा. But generally, बल्कि in fact हो जाएगा. हमने that must have been about more about symmetry. वो symmetry के बारे में होगा. If the curves are symmetrical, then you can actually find out um values directly. सही है. इस क्वेश्चन में वो थोड़ा सा डिफरेंस है इसलिए मैं कर नहीं पाऊंगा. Okay, but you can show me a question and then I can explain it to you. Okay, the proportion of people having a particular model medical condition is 1 in 100,000. A random sample of 2,500 people is obtained. So just by reading this question, this looks like a binomial. Okay, a random sample of 2,500 is obtained. The number of people in the sample having the condition is noted by X. State with the justification a approximating distribution for a suitable approximating distribution for X, giving the values of any parameters. Okay, so firstly, this is a binomial distribution. 1 in 100,000 means that the probability is really small, and I have something like this. Okay, 1 over 100,000. So we've learned कि जब binomial की probability बहुत छोटी हो जाती है, if it's less than 10% or 0.1 and n is large, what you do is use Poisson. Okay, in order to use Poisson, you'll need lambda. Lambda is NP, which is 2,500 into 1 over 100,000. Okay, that gives me 0.025. Okay, so the approximating distribution is Poisson with lambda 0.025. Does it say justification? Straight with the justification. So you will say that n is large and p is less than small. Okay. Here it says greater than 50 and it says np is equals to less than 5, or it also says except that p is small. Okay, you can also use that. Then it says use the approximating distribution to find the probability of x greater than 0. X greater than 0 simply means 1 minus probability of 0. So it means 1 minus e power minus lambda. 0.0247. Okay, that's the correct answer. Then it says the percentage of people having a different medical condition is thought to be 30%. Point 0.3. A researcher suspects that the true percentage is less than 30%. So this looks like a hypothesis question. And it says it tested the 2% significance level in a medical trial. A random sample of 28 people was asked, and 4 people. This is your test statistic. It's found to have this condition. Use a binomial distribution to test the researcher's claim at the 2% significance level. Whenever the question is about hypothesis testing, you should clearly state out your null and alternate hypothesis first. Okay. Then you know that you have a binomial distribution and your test statistic is 4. So you will calculate the probability of x less than or equals to 4. So you will need the probability of 0, 1, 2, 3, and 4. Okay. Now write out these probabilities. It's 28 C0 Q power 28 P power 0, 28 C1 0.7 power 27, 0.3 power 1, 28 C2 0.7 power 25, and 26.3 power 2, 28 C3 7 power. I just have to write these out, then I can use my calculator to calculate it. Uh, did you do it, Hamna, using a calculator? कौन सा वाला calculator है आपके पास? White वाला? You know the white calculator helps you calculate probabilities directly, right? I'm just verifying my 0.0474. ओके इन एनी केस अगर आपको कैलकुलेटर की यूजेज की वीडियोस देखनी है तो मैंने अपने यूट्यूब पर अपलोड की हुई है व्हाट आई डिड वाज देयर इज जस्ट वन फंक्शन ऑन द कैलकुलेटर दैट कैलकुलेट्स द टोटल ऑफ ऑल ऑफ दीस so you can use that on the exam as well. Okay. So 4.74% is greater than 2%, greater than significance level. So your decision should be accept H naught. Okay, what will be my conclusion if I'm accepting this and rejecting this? I will say that this researcher's suspicion is not correct. Researcher's suspicion is not correct. There is not enough evidence to suggest that the proportion has decreased. Okay. What do you mean sign level questions? Sign level का क्या मतलब है? Significance level. अच्छा बाइनोमियल में जरूरी नहीं होता. नॉर्मल वाली जो टेस्टिंग होती है उसमें ज़रूरी होता है, जहाँ म्यू का टेस्ट कर रहे होते हैं. ज़रूरी उसमें भी नहीं होता, वो अपने सपोर्ट के लिए होता है. यहाँ पे डायरेक्ट सपोर्ट और डायरेक्ट आप सिग्निफिकेंस लेवल से कंपेयर करते हो, वहाँ पे टेस्ट स्टेटिस्टिक निकालना पड़ता है. ज़रूरी किसी में भी नहीं होता. ओके. The random variable t denotes the time in seconds for 100-meter races run by Dania. T is normally distributed with mean mu and variance sigma square. A random sample of 40 races by Dania gave the following. N equals to 40, sum of t is this, estimate unbiased estimates of these. So 560 over 40 हो जाएगा ये. 14. Okay. So और sigma square निकालना तो मुझे क्या लिखना पड़ेगा? I will have to write 40 over 40 minus 1 into 7850 over 40 minus 4. Okay, that's the answer. Okay, then it says the random variable S denotes the time in seconds for 100-meter race is run by speech. S has the independent distribution. This use your answer to part A. Find the probability that in a randomly chosen 100-meter race, Suki's time will be at least 0.1 more than Tanya's time. So let me just write the distribution for Tanya's time. Tanya's time is normally distributed with 14 and 0.2564. 2564. So what I want is that I want Suki's time will be at least 0.15 more. So I want the difference between Suki's time to be greater than zero point 0.1. So I'm going to have to construct a new variable called difference and say that this is S minus T. Now difference will have the normal distribution with 14.2 minus 14, comma, 0.3 plus 0.2564. Okay, so probability of difference greater than 0.1. So yeah, so you're telling me the probability of 0.134 is 0.55. Okay, that's the correct answer then. Okay, then it says the masses in grams of apples from a certain farm has have mean mu and standard deviation that farmer says that the value of mu is 64.6. A quality control inspector claims that the value is actually less than 64.6. So again, looks like hypothesis testing. It says carry out the test. So I start accumulating the information that I have. Mu is 64.6. Each one says that it's less than 64.6. In order to test the claim, he chooses a random sample of 100 apples from the farm, the mean of mass of 100 apples. So n is 100. The test statistic is 63.5. Okay, carry out the test of the 2.5% significance level. So I draw my rejection region, 2.5% significance level. So I'm going to read 97.5 from the table. 97.5 is 1.96. So this is minus 1.96. Z value of test statistic. So 63.5 minus 64.6 divided by 5.2 over root of 100. Minus 1.525. So is this value in my rejection region? No, it's not in the rejection region. It's outside the rejection region, minus 1.525. So it's in the acceptance region. So I'm going to accept H naught. Okay, not enough evidence to conclude that mean has decreased. Okay, did I calculate it wrong? Let me check my calculations. Have I done a calculation wrong? Can somebody check? Oh, my calculation is wrong. Sorry. Which is why I got the wrong answer. No, it's minus 2.115. So it is in the rejection region, right? Reject H naught. Mean has decreased. This is in the rejection region. Okay. Calculation actually मैं तो जल्दी जल्दी कर रहा हूँ तो फिर also. Okay. Then it says later another test of the same hypothesis at 2.5% significance level with another random sample of 100 apples from the farm is given that the mu value is in fact 62.7. Calculate the probability of a type 2 error. So type 2 error जो होता है, it's the probability of acceptance region with new mu. Now, I don't know the rejection region right now. Okay, I just know the z value of the rejection region, which is what I'm going to use. I'm going to say that पहले ये z value जो है मैं इसको जो है वो x bar में convert कर लेता हूँ, so that I know what my rejection region and my acceptance regions are. So I'm going to say 1.96 x bar minus, let's take the old mean first, 64.6. I'm going to convert this minus 1.96 into a okay, 0.52 into minus 1.96 plus 64.6. So x bar is 63.581. Okay, I can say that this is 63.581. What was my rejection region? X bar less than 63.581 is the rejection region. If I want to find the acceptance region, it's the opposite of that. I'm going to say that the acceptance region is greater than 63.581. How am I going to calculate the probability? I'm going to use the mu. The standard deviation stays the same. Because rejection region जो होता है वो पता होना चाहिए ना. In order to find the acceptance region, you need to first know the rejection region. Okay. इसीलिए question 5 marks का. Does that make sense? देखो अभी मैं दिखा रहा हूँ, एक मिनट, just let me write this. 63.5 बेटा, 63.5 तो कहीं यहाँ पे अंदर आया था ना. It wasn't the start of the rejection region. वो rejection region के अंदर एक value थी. Rejection region start कहाँ से हो रहा है मैं ये आपसे पूछ रहा हूँ. Okay, ये तो कहीं दूर जाके आ रहा है ना यहाँ पे. Okay. 1.694. जल्दी से 1.6.9549. Right? That's the correct answer. Okay. That is one paper.